as I told you, I wanted to give you a little bit of information about made-up operations before we actually start to work on them Monday in class. So the first thing students think when I talk about made-up operations is, what the heck is that? And it truly is a made-up operation. You're very familiar with the four operations: addition, subtraction, multiplication, and division, and you will try to fit this process into those molds. However, I'm going to warn you, a made-up operation is just that. There are two types that we'll be looking at. One is a rule, so we'll be looking at the rule, and the rule actually gives the definition of the operation. In this example, it has A delta B equals 3 times A times B. And how I want you to think about that is, if I have two elements, this is the first element, and this is the second element. When I perform the operation delta, that generates 3 times the first element times the second element. That's all you know about operation delta. And we're going to actually compare this to the properties that we just went over in section 1.5. We're going to take a look at that in just a few moments. And I know that's a lot for you to think about. It'll make a little more sense as we walk through the first example on this video. The second way we're going to look at is by using a grid. And the grid actually gives you the definition in terms of a set. So if we look at this grid, tilde, I'm going to define it by the operation tilde. The set of numbers that defines tilde is the set that's across the top in this first row and down this column. So you can see that this is actually the body of the result when you perform the operation tilde on two elements of tilde. So my set would be 1, 2, 3, and 4. And when I look at this, how I would read this, for example, if I had 1 tilde 3, and I wanted to find that value, I would go across the top to 1, down the side to 3, and where they intersect, that's the value of 1 tilde 3. So when I perform the operation tilde on those elements 1 and 3, I get a 1. I know that all looks pretty foreign and probably pretty confusing at this point, so let's actually take a look in a little more detail at the rule to start with. So I have this rule, A delta B equals 3AB. And what I want to do is test the properties that we have learned about: closure, commutativity, associativity, inverse and identity, and distributive property, to see if the operation delta holds true. So when I look at this, I have 3 delta B equals 3 times A times B, and A and B are real numbers. I know that 3 is a real number, so therefore, when I have A delta B equals 3 times A times B, I'm dealing with all real numbers. So therefore, since A and B are from the real numbers, the operation delta generates 3AB, so that this result is included in the set of real numbers and therefore it is closed. So it has the property of closure. Closure simply means that when I perform the operation against two elements, the result is in the set that those elements came from. Remember the definition of commutative. Commutative says if I take A plus B, that should be equal to B plus A. So let's look at the property of commutativity in regard to this rule. So I have A delta B should be equal to B delta A. Well, remember, go back to your rule. A delta B generates 3 times the first element times the second element. On the other side, B delta A generates 3 times the first element times the second element. And now, because the operation between those is multiplication and multiplication is commutative, the operation delta is commutative because you can see that these two are clearly equal. So for the operation delta, the answer for commutativity is yes. The next one can get a little confusing, so I'm going to try to put some more parentheses in to try to help you understand that. Remember, with associativity, associativity says that the order in which I add the elements together doesn't matter. So I want to test to see if that's true for my operation delta. So for this, I'll need 3 elements. So I will have A delta B delta C is equal to A delta B delta C. So now you have to go back to your rule. A delta B gives you 3 times the first times the second, which is going to give me 3AB delta C. On the other side, I have A delta, I have to do the parentheses first, B delta C. So that's going to generate 3 times the first element times the second element. So now I have to perform the operation delta again. This time, 3AB on the left-hand side is my first element. That sometimes can be difficult to see. 3AB is the first element. So when I perform the operation delta, the result is 3 times the first element, 3AB, times the second element, C. On the right-hand side, the second element is 3BC. So when I perform the operation delta, I'm going to get 3 times the first element, A, times the second element, 3BC. When I multiply those all together, I have 9ABC equals 9ABC. Clearly they're equal, so if you ask the question, is delta associative? The answer would be yes. We'll see some examples next week of when there is not, and when it's not commutative and when it's not associative. Let's see, next we have the identity, and I've put all the definitions here so you can kind of see those definitions again. So the identity says if I take the first element, perform the operation against the identity, I get the first element back. Well, I know that by definition of the operation, A delta I is going to generate 3AI equals A. Solve this for I because you're looking for the identity. So divide by 3A. So I is equal to 1/3. The identity must be unique. Must be unique. It cannot have a variable. Because it's the identity. So it must be unique. Also, if there is no identity, there will be no inverse. This we see, however, does have an identity, and the identity is 1/3. The next property we're going to test for is the inverse. Now remember, the definition of the inverse is that you have the element perform the operation against the inverse and you get the identity. So if I have A delta V, that should give me the identity I. A delta B will give me 3AV, which should be equal to the identity, which we just found to be 1/3. Solve that for V by dividing both sides by 3A. Oh, look, there's a compound fraction. I'm going to get V is equal to 1/3 over 3A. Put that over 1 and then solve that compound fraction so that you get the inverse is equal to 1/9A. The distributive property, we actually need two operations, and we don't have those, so we're not going to be able to continue on with the distributive property. We're going to test these same properties when we use a grid, as in this previous grid. We're going to try that with those same properties on Monday, and then we'll actually do the notes for you to actually record in your note packet. I just wanted you to have a preview of made-up operations so you could become a little familiar with it, and that you might have some questions prepared on Monday so we can talk about that. Okay, have a nice weekend. I'll see you Monday.